Okay, so today what we are going to discuss means Prometheus and Grafana. This will explore. Okay, so first complete infrastructure monitoring using Prometheus and Grafana. Make sure last class we discussed about Nagios. Nagios is also monitoring tool where we'll use Nagios to monitor the resources like CPU, memory, disk, memory, SQL queries, then network bandwidth. Like this, plenty of things you can able to monitor using Prometheus and Grafana. Majorly, where it is going to utilize useful means majorly into microservices architecture. We have mainly two types of architectures. There one is monolithic architecture, another one is microservice based architecture. Monolithic architecture, nothing but single instance, running your application on single instance, one server, one instance, one application. That is called as a monolithic. Microservices means one server, multiple applications, multiple containers running in this particular infrastructure. That is called as a microservices based architecture we used to call. That's the place this particular monitoring will be coming to picture. Prometheus and Grafana one. Okay. You can see infrastructure monitoring is a critical aspect of DevOps, enabling proactive detection and resolution of the system issues. I mean, in system enforcing any of the issues means that's our responsibility that we need to detect that issues and we need to resolve the issues. This project focuses on real-world infrastructure monitoring using Prometheus, Grafana, and some other tools like Loki, Mimir, like this. Multiple tools will come. Okay, dynamically to monitor the Docker, Kubernetes, and AWS resources. The monitoring stack provides insights into health and performance of the containers, Kubernetes clusters, and cloud-based resources, ensuring the efficient system operations and the resource utilization. So that means we can able to track that what are the things are going on in your cluster, what are the issues that will be coming up, and memory issues, CPU issues, or application level issues. Those issues, everything can be monitored using this particular stack. The primary objective of this project is, if you can think, to set up a Prometheus and Grafana for real-time monitoring, to collect the metrics from Docker containers using CAdvisor, to monitor Kubernetes clusters AWS EKS with Prometheus and Grafana, to implement Loki for centralized log monitoring, and to create dynamic dashboards in the Grafana for visualization. So that means we can able to monitor the things and we can able to look for that as also. So what are the technologies we use it here? If you think about that, majorly AWS cloud, because all our infrastructure will be running in AWS cloud only, right? Cloud computing platform used for deploy and manage infrastructure resources. Prometheus, an open source monitoring system for collecting the metrics from configured targets at the given intervals. Then Grafana, a visualization tool that is used to create dashboards and display the real-time monitoring data from the Prometheus. So remember guys, Prometheus will get the data and Grafana will going to visualize. Visualize means graphs it will going to create. But if at all you want to create a graphs, we require a source for that, right? The source is getting from the Prometheus. Then Loki, a log aggregation system for collecting and storing the logs efficiently. Then we have a CAdvisor, last one, a container monitoring tool used to track the resource usage and performance metrics of the running containers. So how to set up? We need to create a server and we need to deploy Prometheus and Grafana on the AWS instance. So we can configure Prometheus to scrap the metrics from various targets. Create a Grafana dashboard, visualize. Okay, installation part is the next. Okay, what I'm gonna do means, so let me do the practical for this. Here I can go. Let me start the server. In this server only I'll do. We can refer this one. This is having the how we can able to install the Prometheus and Grafana. There's a GitHub link will be there. We can refer this link and we can able to do that. Okay, let's understand here. When you talk about the introduction part of the Grafana wise, this section provides a basic information about observability topics in general and Grafana in the particular. These topics will help to just starting out the observability and monitoring. Remember guys, when the person talked about observability and monitoring is the main tool which will come into picture in our mind is Grafana and Prometheus only. Make sure that Grafana is an open source tool. Remember, Grafana open source is an open source visualization and analytics software. It allows you to query, visualize, and alert on and explore your metrics, logs, and traces, no matter where they are stored. It provides you with the tools to turn your time series database, TSBD we used to call. TSDB means time series database data into a insightful graphs and visualizations, nothing but this will going to convert, the Grafana is going to convert TSDB time series database data into insightful graphs and visualization. That means it will convert as a graph and visualizations. There we gonna use Grafana Loki. Grafana Loki is an open source set of components that can be composed into a fully featured logging stack. Okay, that means it's going to convert as a logs. Grafana Tempo. Grafana Tempo is an open source, easy to use and high volume distributed tracing backend. Mimir also can be used. Mimir is an open source software project that provides scalable long-term storage for Prometheus. Then Pyroscope is there. Grafana Pyroscope is an open source software project for aggregating continuous profiling data. Continuous profiling is an observability signal that helps in understand your workloads, resource switches like that. There are multiple options are there. In that, Prometheus is the main one. Observability process focuses on understanding the internal state of your systems based on the data that you produce, which helps to determine if your infrastructure is healthy. Prometheus is a core technology for monitoring and observability of the system, but the term Prometheus can be confusing because it is used in different contexts. Understanding Prometheus basics, why it is valuable for system observability, and how users it can practice it will both you better understand that it will be Grafana. For example, Grafana began in 2012 at a SoundCloud because existing technology were insufficient for their observability needs. Prometheus offers both a robust data model and query language. Prometheus is also simple and scalable. In 2018, Prometheus graduated from Cloud Native Computing Foundation CNCF incubation and today is thriving the community. Remember how Prometheus as a data it looks like. Look at here this diagram. The following panel is a Grafana dashboard, shows how much disk bandwidth on a Mac laptop is being used. The green line represents the disk reads and the yellow line represents the metrics. Disk IO dashboard we used to call. Data like this from the time series. X is the moment in time and Y is the number or measurement. For example, 5 megabytes per second. This time series data appears everywhere in the system monitoring. Okay, like this we can able to monitor. But main thing, Prometheus can use the PromQL like this. PromQL is there. This is a language. Prometheus can be used. Like the graphs will be printed. Make sure. Let me log into the server first. Okay, I'm able to log into the server. The first thing what is recorded in this server is Docker. Docker is installed or not, we need to see. Then Docker Compose is there or not, we need to see. If it is not there, we need to do the installation. Docker Compose is not there. Okay, we need to install a Docker Compose. This much code is enough. VI Docker -compose sh. Now it's installed. Okay. Now the Grafana is this was installed. Let's will move for analyzing this. Okay. This is the GitHub link. This link contains the how we can able to enable the monitoring solution with the Prometheus Grafana, C Advisor, Node Exporter, and Alertmanager. Okay. So monitoring solution for Docker host and containers with Prometheus Grafana, C Advisor, Node Exporter, and along with Alertmanager. How to install that? Clone this repository on your Docker host and cd into the doc prompt directly and run the compose up command. So that means first I'll go with this, get inside the folder. Then we can get inside the folder like this. Once we cloning is done, here if you can see the code is there. So for creating and launching the containers, before that let me see any containers are there. Docker images, Docker ps, nothing is there. Okay, it's empty. Now we can able to execute the things. So how to execute means we need to run nohup nohub docker docker -compose up up ampersand. This command we need to run docker -compose up up then ampersand. Now this is trying to creating the resources make using this particular GitHub link. Let's will see what are the resources it was created and how to verify. We can tile the no file. Look at it started creating the resources, it started downloading the required things. I think it was done. How to verify? We can able to do docker -compose images. This will go to list out the images. You can see Alertmanager, caddy, C advisor, Grafana, node exporter, Prometheus, push gateway. Like that, multiple images has been created. Docker, compose, PS. These are the containers are running. Above ones are the images, below ones are the containers. Now everything is good. These are the important things now. Make using this only, we can able to log in. You can see first along with the port numbers. So these are standard port numbers, guys. Look at Prometheus. We have a matrix database, IP http:// low host IP address, then 9090 port number we need to use. If you use 9090 port number, then Prometheus can load from that one. Then same IP address 9091, it will use Prometheus push gateway, like push acceptor for ephemeral and batch jobs. Same way, Alertmanager 9093. Grafana you want to access visualizing the metrics 3000. Like this particular IP address colon, this particular port number should be used. Let me get the IP address first. I'll open the incognito window. Colon 9090 first. Same way 9091. colon 3000. Like this, one by one we need to open. Like this, if you open, right, it asks for a username password. You can see it's asking for username password. What is the username and password? Admin. So username is admin, password also admin. Then sign in. Similar way here also. Same thing, admin. It has to change the password, but I don't want to change. I'm skipping this. Now you can see this is the Prometheus. This is a Prometheus push gateway, Alertmanager, then Grafana. So like this, the things will open. Okay, I'll paste it, guys. You guys also can, if you want, you can access these things. Anyway, you guys know about the username password, right? Admin. Username is admin, password is admin. You guys, you just try to access this. Open this URLs in the incognito window and put the username password. It will ask admin. So that you guys can experience what I am doing. But we can change the password any moment. Okay, here this is the option we have. We can able to change the password anytime. Okay, so then caddy v2 does not accept plain text passwords. it must be provided as a hash value. The above password hash corresponds to admin password. Admin to know how to generate hash password, updating caddy to v2. I mean, that's a different one. Ignore. This we understood. Setup Grafana, if I talk about. Login with the admin and admin. You can change the credentials in the compose file for supplying the admin user admin password variable and the compose app. The config file can be added directly in the Grafana part like this. Like in the configuration, we can add the username, password, allowing sign-in calls we can able to add, and we can able to do that. So in the password, you have to remove this entry, otherwise change will not the effect. Okay. Grafana is pre-configured with the dashboards and Prometheus as the default data source. Name Prometheus, type Prometheus, and IP address access. So like this is the Grafana dashboard, guys. Like this, the dashboard will be looks like. Let me show that, then we can understand that. Where is that? Here. Okay. What we need to open here is first we'll open the Docker host dashboard, shows the key metrics for monitoring resources used on the server. Look at it, guys, how I'm opening. You guys also can open. Left side we have a dashboard, so there click on dashboards. You can see Docker host. There are 4 dashboards are there. You can click on Docker host dashboard. Along with me, you guys also can open, please, so that we can understand. Now graph is opened. What are the things that there? Let's will try to understand from the layman perspective and from the observability and monitoring perspective. So the first thing, server uptime. Which is server uptime? This is the one. This is the uptime of the server. If you have any confusions, now we can do like this. We can type the command called uptime. This will going to give the clear time, what time the server was up. Look at 17 minutes ago. Here what is reflecting? 17.6 minutes ago. That's correct. Then CPU idle percentage. Second one is CPU idle percentage. This is the idle percentage. 100% if we take that out of 100%. So idle means nobody is using that. Simply setting. That is 92.6%. Then how much is using then remaining? Close to 7% only using. Then the server what we are using, that is T2.micro. T2.micro can come up only 1 CPU and 1 GB memory. That's the reason cores, CPU cores 1 is there. That's only 1 CPU. That's the reason 1 core is there. Then available memory, if you see that 224 MB is there. Let's will analyze how much is the available memory. How to check that memory in the Linux server, guys? What command will you use? What command will use to check the memory in the Linux? Sorry? df-h. That is for disk. We need to see memory. FREE free minus M. Able to see 216. How much is here? Same, near to 221 something, in between lying. Swap 0. Why swap 0? Here also swap 0 only there. But storage is not getting up. But we need to look for that. We'll check that. Available memory, swap memory, and storage. Then second row, if you see system load average graph. This is the one. System load average graph. How much load is taking. Then running and blocked by IO process graph. Interrupts graph. This is the process graph. This is the interrupts graph. Then CPU usage graph by mode. Guest, idle, IO wait, IRQ, nice, soft IRQ, stale, system, user. But if you can see here, those everything is getting up. Idle, user, stale, system, IO wait, soft IRQ, IRQ, then nice value. Memory usage graph by distribution. User, free, buffer, caching. This is memory here. You can see. Same, whatever the value you're seeing there, same value is reflecting here also. User, cached, free, buffers. Then IO usage graph. Read BPS, write BPS and IO time. This is the one. Read, written, IO time. Like this, we can able to monitor. Next to network usage. Network usage graph by device. Inbound BPS, outbound BPS, swap usage and activity graphs like this. These are swap usage. These are IO activity of the swap. Like this, we can able to analyze the graphs. Okay. Now storage graph is not coming up. Look at guys, this one. Yes, storage is not working. Free storage is not coming up. We need to see why it's not coming. We need to debug that. So for storage and particularly free storage graph, you have to specify the FS type in Grafana graph request. You can find it on Grafana bar provisioning bar dashboards slash docker underscore host.json file at line number 480. It was there. From there we need to monitor. So before that, I work on BTRFS, so I need to change to AFS to BTRFS. But you can find the right value of your value in Prometheus. So we can copy this value and we can run this value in the Prometheus. It is a Prometheus, right? We can copy paste this value, and if you run it, this will going to show the value. See, this is the value is reflecting, but I am not understandable this value. Then cap 3 slash Python slash 1024 cap 3. Let me see what value we'll get. We'll get this by using GB. If you guys run this command, query will get in GB. Look at, I'm getting that GB. What is the value we're trying to fetch? Node file system free bytes, nothing but disk. We're trying to achieve the disk. So you can see this much is there. Next, I said we need to change that value, right? We need to change the values. One query at a time. So this is the way you can fetch free bytes also. Plus available bytes, these are free bytes. This two also we can able to run it in the so that we can able to see the graphs. Let me do one thing. I can change this here, edit. Here the query will be there. I'll use this query. Here AUFS is there, but ours is XFS. So I'll modify this query. Look at my output is came like this. Query will be there. You need to edit and you need to use that. Just refresh this value so that you will get the right value. Look at now graph is coming up. Let me save this one. Docker host. Able to see earlier NA is there, now value is getting up. Similar way, what other graphs are there means container graphs are there. Let's will see the container. Look at CPU load of the containers, or how many core of CPU, memory, user memory, storage load, user storage, like this multiple things are getting up. But if you can see here one thing, container CPU usage is not getting up, or no data is getting up. Why is not getting? We need to see that. We can go to edit symbol. The three dots will be the right side. If you click on edit symbol, here you need to change that. So nothing but something we need to change. Image not equal to this, we need to change. Okay, image not equal to, if you change that, let me share this one with you guys. If you can see, like saved, okay, back to dashboard, graph is coming up. Similarly, memory also same thing. Their image not equal to or equal to something they put up. This is not the valid one. We need to remove this value. We need to run the query. Save dashboard, save. Memory also getting up now. Then container memory is not getting up. I'll edit this also. This could, like this will be your day-to-day activities generally. This only will get an opportunity to work. Something is not loading, something is not working means it's your responsibility to take care of that. Okay. So I'll be fixing one by one, whatever the things are getting up, right? Those, this is getting up, this one is not getting up, last one. Even if you remove this also, it won't impactful anything to your cluster, your data. Okay. Okay. Like this, we can able to modify the graphs if at all if required. See, all the graphs are working now. Next, we have a monitoring services dashboard also there. Here, how when the Prometheus was started, what is the memory, how many memory chunks, like this complete information is here. We can monitor this all. Total 7 are there. Those are running. And also last one we have a Nginx also we can see, but Nginx nothing is there here. No data because Nginx is not there in this box. Okay, it's already binded to some port number or something. That's the reason it's not taking up, seems to be. No problem. Okay. Nginx is not running. Some port number problem is there here. That's the reason it's having the problem. Nginx is not coming up, but rest of the things are working fine. Okay, like this we can able to use. We can define the alerts also like this. alert details we can able to put up. So particular service is down, what is down, why things like this. Only if you put up the alert like this, you get an alert also. Let me show that how the alert looks like in Slack. Look at it, guys. Like this, you'll get a notification. This particular service was down for a particular minutes. So please check like that. Once you resolve that, you will get like this resolved. Firing means getting the alert. Resolved means you completed the alert. I mean, you fix the issue like this.
So what is the issue with Nginx? Because it's running in the server, no?
Server is running, sir. Nginx required a configuration file, right? Nginx.conf. That is not there.
Okay.
That's not there. That's the reason it's failing. Okay, like this, majorly we can monitor the things. What will get an opportunity to work here means majorly this type of things only means opening the looking at these values. Those only majorly will get.
Nagios is used for only for single application, no, sir?
Exactly. This is for majorly multi-container. I mean container infrastructure majorly this one.
But nowadays nobody is using this one, no, sir. Single instance architecture. Most of
Everybody
them are already implemented with microservices.
correct. Like this, multiple options are there. Alertmanager discovery. Like this. Annotations like this also, which can show that. Okay. Like this, you guys can able to scrap the data using Prometheus and Grafana. When you join the organization, definitely Prometheus Grafana already there it be there. You just need to monitor the things. That's it. That's the opportunity you will get.
Which are the monitoring tools are there apart from Nagios and Prometheus Grafana?
Nagios,
And this one, Neuralink is, I think it's enterprise based most probably.
Neuralink, Jobix, Datadog, Dynatrace, Check MX. Like this, plenty of tools are there, sir. But
But
nowadays,
those are not, sir, those are all enterprise level, I think.
some of them are enterprise level, license based. Open source, more rich features offered by this one only, Prometheus and Grafana only.
But this is not free, no, sir?
Prometheus Grafana is free.
Okay.
Prometheus Grafana are free, but other tools are costly.
Okay.
That's the reason people are using this.
Okay. Most of them are using Prometheus Grafana itself, I think.
Correct. Now we need to remove this means docker -compose DOW and down. If I run this command, complete things are removing. Now if you try to access, it won't accessible. Things are gone. An example, see, site can't be reached. Hmm. That's about the part of Prometheus and Grafana wise. Okay. Anyway, I sent all the commands and the things also. You guys also can go through once again. You set up your server and you can do monitoring. Okay. Even you can look for some documentation also. You'll get some enough documentation for creating a dashboard like that. Plenty of things you can do some handwork. Okay. Next class we'll discuss about Splunk. Post the Splunk, we start Kubernetes. Okay, Kubernetes is the last one. Then post that we'll discuss some project and we'll update the resumes. Okay, cool that then. Thank you.
Thank you, sir.